So in this proof, notice it says B is between A and C. That makes me think that I'm going to need to draw a picture because this has to do with segments. So first thing I'm going to do though is copy my given into my first statement. B is between A and C. I'm going to copy on exactly as I see it. Don't change a thing. AB is equal to 3x. BC is equal to 2x plus 10. And AC is 6x minus 40. And the reason is it's given. Okay, I'm going to draw a picture. I'm going to put B. Point B is somewhere between point A and point C. So if I gave you that picture and I said, what conjecture could you make based off of that picture? We could say part plus part equals whole. Part plus part equals the whole enchilada. AB plus BC is equal to AC. So I'm going to put that as my next step. AB plus BC is equal to the whole enchilada AC. And that is called the segment addition postulate. We learned that a long time ago and we haven't really used it in a while, but it's coming back for proof. Segment addition postulate. And you can abbreviate postulate, P-O-S-T. That's okay. So segment AB plus segment BC is equal to segment AC. Now what I can do, I have this nice beautiful equation set up. Now I can go take the 3x and put it in the place of the AB. I can put 2x plus 10 in the place of BC and 6x minus 40 in the place of AC. So that's called substitution. So now I'm going to go substitute my expressions into the nice beautiful equations. So AB is 3x. Plus BC, which is 2x plus 10, and AC is the whole thing, 6x minus 40, and all I'm doing there is substituting, so that's the substitution property. Sometimes people want to jump straight to this step 3, this statement 3, and say that that is the segment addition postulate. But if you're using the segment addition postulate, you should see segments in your statement. So if you just see expressions, numbers, and variables, those aren't segments. First, you have to set your equation up with the segments. Then you can go substitute the expressions into the segment equations. So it's really important that you have those two separate steps. First, you set up the equation with the segments, then you go substitute the expressions in. Okay, now I'm trying to solve for x. That's my end goal. I'm trying to solve for x. So I need to combine like terms. 3x plus 2x is 5x. So 5x plus 10 equals 6x minus 40. And when I'm just combining like terms, that is simplify. Then I want to get my x's on one side of the equation and my numbers on the other side. So I'm going to subtract 5x from both sides, which would give me 10 equals x minus 40. I subtracted the 5x from both sides, so that's the subtraction property. Then step 6. I want to get the x all by itself, so I need to get rid of this negative 40. So I'm going to add 40 to both sides. So 50 equals x by the addition property. I added 40 to both sides. And you might be thinking, okay, I'm done with my proof. I solved for x. Hold up. Check the proof statement. The proof statement says that x has to be equal to 50. Our last statement of our proof says 50 equals x. So it's not identical to what's in the proof statement. So that means that we're not done yet. My last statement has to match my proof statement exactly. So my very last step, step 7, is I need it to say x equals 50. And when you switch the left side of your equation with the right side of the equation, when the left side becomes the right side and the right side becomes the left side, that is the symmetric property. And so now the last statement of my proof, x equals 50, matches the statement that's in the proof at the top perfectly. And so now we are done.